Hello, SAT class. Today we are going to look at SAT style problems that involve systems that can be solved with substitution. All right, so you should have already done your bell work, and so now let's go ahead and look at our agenda. I do want to give you a heads up that next Monday, November 8th, there will be a quiz over solving systems of equations. We will do some review activities on Wednesday this week to prepare for it. You'll also receive a study guide to practice problems on Wednesday. All right, so how does the SAT test systems by substitution? So the first type you might see, just as we saw with elimination, is there might be some x plus y problems. But how this will look will depend on the creativity of the College Board, but there are some patterns to look for. So if I look at this problem right here, you might be thinking, Mr. Bear, we only have two equations, but we have three variables. Well, that is very, very true and good observation for that. But notice they want the value of x plus y. When we look at this system, we have an x plus y in both of these. So what I'm going to do is I'm going to make a substitution. I'm going to let, let's call u equal x plus y. If I do that, then this x plus y that's written right here, I'm going to rewrite that as u plus 3z equals 600. And here, I'm going to write u plus z equals 400. So I'm making a substitution here. And after I make that substitution, this looks just like something that we've been solving. We can use elimination or substitution to solve this. Many of you are probably feeling better about using elimination. I'm going to eliminate those u's. Actually, you know what? Let's not eliminate the u's. Let's eliminate the z's, because if I can solve this for u is x plus y, that'll get us our solution. So I'm going to be strategic here. So I'm actually going to eliminate the z's. So this is a positive 3z. I need this one to be a negative 3z. Okay? So now top equation stays the same. Make sure you're writing this down. Bottom equation looks like so. And the z's are out. We get negative 2u equals negative 600, which means u has to be 300. And remember, u is just x plus y. So this implies that x plus y equals 300. Okay? Okay, let's try another one. Sometimes we have to factor in order to get the quantity we want. So here we see another two equations but three variables. They say if the equations above are true, which of the following is the value of y plus z? So here's y plus z. If I look here, I have 2y plus 2z. Well, if we think about 2y plus 2z, what can I factor out of that? Well, both terms can be divided by 2. So I can write that as 2 parentheses y plus z. So I'm going to think of this as 2 parentheses y plus z. And so now I have the equation, and then I'm going to let u equal y plus z. So now my system of equations will look like 3x plus 2u equals 19, and 3x plus u equals 14. And we're asked to find the value of y plus z, which is now our u value, because we let u equal y plus z. So now we're going to solve by, again, you could pick your method, but I'm going to eliminate the x's in this case. So I'm going to multiply the second equation by negative 1. So the top equation will stay the same, and the bottom equation will look like this. X's are gone. 2u minus u is just u. U equals 5. And remember, u is just y plus z. So that means y plus z equals 5. So choice E. All right. let's try another one here. This one here, we want to find the solution, the ordered pair that makes this system true. What I notice here is I've got a 2y plus 3 right here. Where does factoring take place? Where else can I make a 2y plus 3? Well, if you look at this 4y plus 6, that's the same as factoring out a 2, and you'll get 2y plus 3. So what this means is that negative 2x equals 2 times the quantity 2y plus 3. And you might be thinking, why in the world would I need that? Well, if I divide both sides of this equation by 2, I get negative x equals 2y plus 3, which then means that this 2y plus 3 in the denominator I can replace with negative x. So I have 2 times negative x equals 3x minus 5. And then I could just solve this for x. That gives me negative 5x equals negative 10. Whoops, negative 5. Not sure why I put negative 10 there. Which means that x equals 1 when I divide both sides by negative 5. Okay? So you know x is 1. We can eliminate c and d. Now to find y, we just pick one of these equations and plug it in. So let's see. Let's use the top equation. So negative 2 times 1 equals 4y plus 6. I'm going to solve this for y, so I'm going to subtract 6 on both sides. And then I'm going to divide by 4, and negative 8 divided by 4 means that y equals negative 2. So the choice has to be B. Okay. Now some of you might have gone about this problem a different way. You might have said, oh, Mr. Bear, why couldn't I have just divided this first equation, just divide everything by negative 2, and then I'd have x equal something, and then replace the x. You could have done that. No big deal. All right, let's go ahead and look at, so this one, if we were doing this on a whiteboard, I would be asking you to try this out for yourself. So I'm going to pause the video, let you try this out, see if you can do it, and then check your work. If you did this correctly, you would have gotten P is 12. What I did was I saw x equals 3v, but that v I know is the same as 4t, so I just replaced the v here with 4t. And then I know that x is also equal to pt, so I replace this x here with pt. So pt equals 3 times 4t, which means pt equals 12t. And because the p and the 12 have to be the same to make this equation work, excuse me, we say p is 12. So we can also see some k-value type problems like we saw in the last lesson, well, 2 lessons ago actually. So K problems, remember these come up a lot when we want to analyze the number of solutions that there are in a linear system. So let's remind ourselves what we get. So if there's one solution, it looks like x equals a number or y equals a number. No solution will look something like 0 equals another number. And infinite solutions will look like 0 equals 0. In the cases of this, the variable, well, it depends on if we're eliminating or substituting. So when it comes down to these last ones, it doesn't necessarily have to be the number 0. I could just have number equals another number. And on this one, I have number equals same number. Okay, so those are other situations that could come up with these k values. All right, so let's try this one. For this one, it says, for what value of k will the system of equations have infinitely many solutions? Okay, so we could do this a couple of ways. We could substitute into the y this 1 minus 2x. We could do that. And we'd have 6x equals k times the quantity 1 minus 2x equals 3. whoops, not 6x equals, but 6x plus. And then when we do that, we have to distribute this k. And then this gets really weird because it's like, well, what do we do with, I mean, we've got all this other stuff going on. So if this is confusing to you, and I'm looking at it, and it's not confusing to me, but I can look at it from a student perspective and be like, ew, that doesn't look good. What I would probably do instead is get this to where I can have elimination. So I want to line up my variables. So I'm going to add 2x to both sides. So I get 6x plus ky equals 3, and then 2x plus y equals 1. And then this might become easier because then we know that we want to cancel out the x's, so we multiply the bottom equation by 3, negative 3 rather. And then the x's are gone. These are also gone. So we need the k's to eliminate, so k has to equal 3. Okay, and that would actually make life a lot easier for you. So notice I said you can honestly use whatever method you want. It looks like a substitution problem, but really you can make it an elimination problem. For the next one, this one we won't necessarily solve the equation with substitution, but we will use substitution in our answer. So in the system of equations above, a and b are constants and x and y are variables. If the system of equation above have no solution, what is the value of a over b? All right, so we need to eliminate the y variable so we can figure this out. So to do this, I'm going to look at the 9 and the 4. The LCM of 9 and 4 is going to be 36. So negative 9 times 4 makes that a negative 36y. So then I need to multiply the bottom equation. I need to make this a positive 36, so I need to multiply by negative 9. So give me positive 36y. Now I'm just going to multiply everything else. So I get 4ax minus 36y equals 28. And on the bottom row, I get negative 9bx plus 36y equals negative 45. Now we want no solution. So that means I need the x's and the y's to cancel out, and the y's already do. In order for these to cancel out, I need 4a minus 9b to add to 0, which means that 4a has to be equal to 9b. So I'd add 9b to both sides. Now, when we look at this, I could then decide, all right, so they want us to know what is the value of a over b. So actually, I'm going to divide both sides by 9b. That gives me 4a over 9b equals 1. And to get a over b, so think of this as 4/9 times the quantity a over b equals 1. To get rid of that 4/9, what I'm going to do is I'm going to multiply both sides by 9/4. The 9's and the 4's cancel, so you get a over b equals 9/4. All right? That one was a little tougher, I know. But that's how you would do it. All right, so the rest of the time you're going to work on some problems on Delta Math. Make sure you complete the Skill 13 BIP. If you finish early, make sure that you finish these skills, Skill 11, 12A, 12B, and 13A. That will get you caught up for the quarter so far. And then if you are caught up when you're done with 13B, then work on assignments for your regular math class.